Welcome to qnawire.
In this problem, the first step is to figure out which way the box will accelerate. And the answer is that it'll accelerate up, since the 96 newtons of force applied overpowers gravity. And it overpowers gravity because m times g is the force of gravity. And since mass is 5 and g is 9.8, I get a value of 49 newtons. And so even though the force is being applied at an angle, it is so large that it overpowers this. And you can check that the vertical force of the applied force is greater than this amount. But once you realize that the box is going to move up, then you realize that the friction force is going to be in the downward direction. And so when we construct our force diagram, we're going to have two forces downward, mg and the friction force. We're going to have a normal force to the right because it's resting on the wall. And so there needs to be a normal force to the right so that the boat doesn't go through the wall. And then there's an applied force up this way at an angle of 60 degrees. And so sum of the forces in the x direction is equal to 0, since the acceleration in the x direction is equal to 0. By the way, I should set up my coordinate system. Positive x will be to the right, and positive y will be upwards like that. And we also have an acceleration in the y direction upward. And so back here, sum of the forces equal to 0. This implies that n minus f cosine of 60 is equal to 0, which tells us that n is equal to 48 newtons. Once you plug in what f is, it's a given. This immediately tells us that the force of friction, which is equal to the coefficient of kinetic friction times the normal force, is equal to 4.4 newtons after we plug in 0.3 here, which is also a given. Now that we know what the force of friction is, we can apply Newton's second law in the y direction. So sum of the forces in the y direction. In this case, it's not equal to 0, since it's accelerating in the y direction. It's just equal to this. This implies that the applied force times sine of 60 minus friction force minus mg is equal to mass times acceleration in y. These have minus signs on them because they are directed in the minus y direction. Now, if you solve this for the acceleration in the y direction, because mass is known, we just figured out what this is, and f is known. And so we just solve it using a calculator to find the acceleration in the y. I get 3.95 meters per second squared. Now, because the acceleration is constant, we can use a kinematic equation in order to find out what we actually want to find out, which is the velocity after it has traveled 0.4 meters. And so just writing down our knowns, y minus y naught, which is the distance traveled, is 0.4. Initial speed is 0. V is our unknown, and the acceleration is 3.95. And so to solve this, I'm going to use this kinematic equation right there. Now this term goes away since v naught 0, and you just plug in these values here into here, and then take the square root. And you get that the velocity is 1.78 meters per second. And that's the final answer to the problem.